Is it working? Good, we're live. All right, so here's how this works. So today it's 3:22. We're going to be talking about inverse functions. Okay, and to do an inverse function, we have any point has some x, y value. We use this symbol here, p negative 1 becomes yx. Okay, write that down. Okay. So any point, p is a point. Okay, that's all. Any point to get its inverse, and this is the symbol for inverse. Okay, that's the symbol for inverse. P negative 1. We just switch them. So if you take any point x, y, and it becomes a yx, that's an inverse relation. Now the problem is that, I'm going to show you a couple of examples, right? So if I had points like this, okay, I just want to show you an example. 1, 2, I got a point here and a point here, okay? Oh, that's a lousy little point. Anyway, let me give you the coordinates. So these two, I'm just going to give you an example. That's 1, 3, and that's 2, 3, right? So I've got this 1, 3, and 2, 3, okay? So these are 2 points. And if I switch them, they become 3, 1. Okay, just switched them. That's all I did, switched them. And it becomes a 3, 2, right? Okay, no big deal, Mr. Davies. What? I don't get it. What are you talking about, okay? So I just switched them. That's all I did. Switch that, 1, 3 to 3, 1. 2, 3 to 3, 2. Every thumbs up, this is easy, right? Do we agree? But the only problem is if you graph these. If I graph these, I'm going to graph 3, 1, which would be here. 3, 1 is here, and 3, 2 is here. The problem we run into is this, and we've talked about it before, that this is not a function. The inverse, so my inverse is not a function. Why is it not a function? Well, okay, so you go to the store. You buy 3 Red Bulls, because that's your life, right? You buy 3 Red Bulls, right? And the darn person at the counter says, well, that'll be $1. Oh, no, that'll be $2. You can't have 2 prices for one thing. Does that make sense? It's impossible. So what we have is an inverse relation, but it's not a function. So to have an inverse function, then we have to have it pass the horizontal line test. Okay? So we talked about functions, and if it fails the vertical line test, it's called the vertical line test because you got 2 y's for 1 x's, okay? Or you get, in the store, you get 2 prices for 1 item. That doesn't make any sense. 2 prices for 1 item, right? But if it fails the horizontal line test, then it will fail a vertical line test. I'll say it again. If the original fails a horizontal line test, when you flip it, it will fail a vertical. So if we check the horizontal line test, we'll say, wait a minute, this thing is a relation, but it's not a function, okay? Okay, let's take a look at number 1 and see what happens, okay? So, number 1, f of x and y are the same thing. So let me just write this as y equals a negative 1/3 x plus 6, okay? Let's see if I can make any sense out of this. I can graph that. You guys, I can graph that, right? Start at 1. Put this in blue. I'll put this in blue. 1, 2, 3, 4, 5, 6, right? How am I doing? Start at 6, then I'm going to go down 1 over 3, down 1 over 3, down 1 over 3, and so forth and so on. Okay, so here is, I'm going to find a ruler. Here's my function, right? There it is. That's f of x. Now if I want its inverse, what I'm going to do is take all of these points and I switch. Okay, so this is a point at 0, 6, right? This is a point at 3, 1, 2, 3, 4, 5. No, yeah, this is point at 1, 2, 3, 4, 5, 6, 4. This is point at 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. So my points are at 0, 6, 3, 5, 6, 4, and 9, 3, okay? How am I doing, okay? So I just graphed, what I did is I graphed my line. That's all I did, is just graph the regular line. Got it. Now if I want its inverse, we talked about you have to switch points, right? Okay, so I graph my line. And then if I want to find its inverse, that's what I'm looking for, I have to switch the points. So I wrote down like all these points. Now what I want to do is switch them. So the inverse would be 6, 0. That's all I just switched it. Okay, switch x and y. And then this would become a 5, 3. This would be a 4, 6, and a 3, 9. Okay, that's all I did. 80.
And then my last thing, I was going to ask how I'm so confused about the domain because it's
All real numbers on both, because it goes for both directions, right?
okay. So just all real numbers.
Yep, yep. So now, you guys okay? I switched it. 0, 6, 3, 5, 4, 6, 3, 9, right? So let's graph these. So if I graph these, 6 zeros, 1, 2, 3, 4, 5, 6. 5, 1, 2, 3, 4, 5, 3. 4, 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. And 3, 9. Yeah. You done? Nice job. Here, if you want, the notes are way up there, okay? And then I can also give you can take a picture of mine to get caught up, okay? And then, so then I also graph 3, 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Just estimate, okay? So here's the inverse. Okay, that is the inverse. So we're going to say, we're going to call that F inverse of x. How's that? Okay, that's my inverse. Now, what if I want the equation of this inverse? Well, what I'm going to do is to get the equation of the inverse, we are going to, again, switch x and y. That's what you do. You just switch x and y. So I have a y equals a negative 1/3 x plus 6, okay? Everything has to do with switching x and y. I know I've said that several times, but that's what you do. So I'm going to rewrite this as, you ready? X equals negative 1/3 y plus 6, okay? And that is this equation, but it's not in a very good form, okay? That is this equation, but it's not a very good form, okay? So I switched x and y because I want the inverse. And now I'm just going to need to solve for y. Okay, so I'll solve for y. Okay, so I'm going to go minus 6, x minus 6 equals negative 1/3 y. Okay. I'm going to multiply you guys by negative 3 because that'll cancel the 3 and the negative, right? So I'm going to multiply this side by negative 3. You see how that'll cancel it out? That's the opposite of this fraction. So cancel, cancel. Negative with negative makes positive. But over here I'll get a negative 3x plus 18. That is the equation of this line right here. So what we're going to say is this. We're going to rewrite it. I'm going to rewrite it. Instead of writing y, I'm going to write f inverse, because that's what it is. F inverse of x. That's the inverse symbol is equal to negative 3x plus 18. Okay, that is my inverse equation. All right, now, one more time. Everything has an opposite. Everything has an opposite. So here was our original line. Here's our f of x. It has an opposite. It has an inverse. This is its inverse. What's the equation of its inverse? Negative 3x plus 18. Okay? All right. Turn the page. How am I doing? Okay? I know. All right. Example 2. Graph x squared minus 9. Now, I know what x squared minus 9 looks like, but if you're not sure, you can just put it on there. You can go, okay, what is x squared? Whoops, clear. what does x squared minus 9 look like? It looks like this. No, it doesn't, because that's a lousy window. Let's go to a decent window, okay? Let's go from -5 to 5, and we'll go from a -10 to, oh, how about 4? Okay, there we go. All right, that's what it looks like, okay? But I can do this, so I know that I'm going to go, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I know how to graph parabolas. We've done this before. 1, 1, 2. I go over 2. 2 squared is 4. 1, 2, 3, 4, 3, 9. And I know it's symmetrical. It's a parabola. So I go like that. Okay, so here's my regular graph, okay? Okay. There, that's it. I mean, I just got that from my calculator, right? Boom. There it is. Okay, so does f(x) have an inverse? No. 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 It does not have an inverse. No. If you were to take this and turn it, it would be a sideways parabola. This does not, it does not pass the, what we call the horizontal line test. So it does not pass the horizontal line test. Okay? So if I were to try and draw a line, straight across, hits it twice, hits it twice, hits it twice, hits it twice. So what we can do is, what we want to do is make it have a function. So we're going to fix it. So what I want to do, right, I'm going to erase this back. If I just get rid of this back half of the graph, it'll work. And if all I keep is just this part of my graph, we'll have an inverse, okay? Because it will pass. There's no numbers, there's no graph over here to hit it twice, right? So to do that, you can't just erase. And this is math. You can't just say, well, I'm just going to erase it. Well, you did. You got rid of the negative part of the graph, right? So we're going to change the domain and say, let the domain be x is greater than or equal to 0. Only the positive values of x. So I'm going to highlight that, okay? So I change the domain to x is greater than or equal to 0. Okay? And now it does have an inverse. That's awesome, okay? So now, if I want to graph its inverse, this is at 0, -9. So I'd have a point at 1, 2, 3, 4, 5, 6, 7, 8, 9. Have a point at -9, 0. This is a point at 1, -8. So I'd have a point at -8, 1. This is a point at 2, I think -3. So I'd be at -3, 2. And then this is the point at 0. I'm sorry, 3, 0. So I'd have a 0, 3. So my inverse graph would look like that. What's the equation of that? Well, so what I did is I took all the points that I could find and I flipped them, right? Flipped them. Everything has an opposite, right? So what's the equation? Well, I'm going to take f of x, same thing as y equals, right? f x, y, same thing. And then I'm going to switch the variables and have x equals y squared minus 9. So I took my equation, y equals x squared minus 9, and I just switched it, right? Switch x and y, okay? That's all I did. So I took my equation. I want the inverse equation now, right? So I switched the variables. Y is x is y. But this isn't a very good looking answer, okay? I need to have the equation of this line right here. So what I need to do is solve for y. And I'm going to do that. Okay, so I'm going to go plus 9, right? X plus 9 equals y squared. And then I'm going to square root both sides. And I have this answer. I've got the square root of x plus 9 equals y. Okay? So then I'm going to write as f inverse because, we're really not y, but how about y inverse? Because that's what we're really trying to do. So instead of y, how about f inverse of x is equal to the square root of x plus 9. Now let's see if that works on my calculator, okay? There's that one. Let's do it. Square root of x plus 9. Now, let me get a little bit more of my window. Let's go back a little further. Here we go, graphic. Okay, there's my parabola, and there it is. Now the problem is that this back half of the graph is not here, because the calculator will graph it. But we erase this, and you can see that fold over here, okay? Last thing before I'm done, okay? All of these, a graph and its inverse, all of these are going to be a reflection over this line. So if I were to fold my graph on this line, kind of like that, it'd fold right down to that, wouldn't it? And on the other side, same thing. If I were to take and, here's my line, let's call the line y equals x. So we're going to say that a function and its inverse, so finally last thing, a function and its inverse are symmetrical. That's like a fold. Whoops, sorry, you can't see this. A function and its inverse are symmetrical. Like it'll fold over on the line y equals x. Okay, that's all I have.